Okay, so let's learn another technique. You kind of did a little one in the opener where you multiplied by, you try to rationalize. So this is a little similar to that. Okay, so sometimes you can factor. In calculus, you'll learn some new things. But the key thing is if you have an indeterminate form, you have to do something different than just thinking about it. Okay, so let's see. So in this one, we got x is approaching infinity. So just kind of imagine you had an infinitely big number in there. The radical would be the square root of infinity, and then you minus infinity. And so it looks to me like that's some infinitely big number minus some other infinitely big number. And so that is an indeterminate form. Okay, so we've got to figure out how to do something differently. Okay, and the key is we want to see if we can get rid of these radicals. So here's the original one. Grab your marker with a different color. Okay, and we're gonna make this look super complicated because it's gonna make it be better for us. So remember, that's weird. So if we want to get rid of these, we're going to try and tie into the difference of squares pattern. So we're going to keep the same two numbers here, but we're going to change the sign in the middle. So we're going to multiply by x squared plus x and then plus x. And if we just multiply the numerator, then we've changed the value. So we're going to multiply by the crazy version of 1. And so we're going to multiply the denominator as well. And maybe you want to add like a 1 over here. So really we're timesing two fractions. Okay, so let's see. So this is the same as the limit as x goes to infinity. You don't drop the limit sign until you can evaluate the new version of the function. That's when you drop the limit sign. Okay, so let's see. So we're timesing these two by each other. So difference of squares says you square the first thing. So it's x squared plus x, and then minus the second thing. You're like, whoo, those go away, which is nice. And then we have this. And the bummer is, if we just try to input infinity again, we would have infinity over infinity. So let's keep on going. And we're going to do something crazy clever. I wish we were together and I'd pass out those magic wands again. Okay, so we've got x. Okay, here's what we're going to do. We want to see if we can factor out. So we're going to take this right here. And what do you have to take the square root of to get to like simplified? You need an x squared. So I'm going to factor out x squared. And then that would leave me with 1 plus. Now here's what kids have a tough time with. What do you times x squared by to give you x? That is 1 over x. Okay, and then you have x. You're like, whew, Miss Brady, that is still crazy. Okay, so let's see. We're going to do another one. Okay, here's why this is handy. And again, like you wouldn't think about this the first time, but once you know this technique, it's something you can use in different situations. So since we're timesing, the square root of x squared is the absolute value of x, but x is positive. So the denominator, this first term is x times the square root of 1 plus 1 over x plus x. Now maybe some of you guys can see that you can reduce out. I'm going to write it factor form. So in the denominator, both things have a factor of x. So I have 1 plus 1 over x plus 1. And why is that nice? Because now this factors out. So let's see what our new version of the function is. Limit as x goes to infinity of 1 over the square root of 1 plus 1 over x plus 1. That's the denominator. And I think I can sort of evaluate this. So let's see, we've got 1 over the square root of 1 plus 1 over infinity. Well, we know that's the same as 0 plus 1, which is 1/2, which is what you got when you used your calculator. We'll practice a little bit more on the next day's opener, but this is like our new strategy. Okay, now let's do this one. You ready? Okay. So again, now if you try to put 0 in, you will get the square root of 9 plus, minus 3 over 0, which is 0 over 0. You're back to an indeterminate form. Next year in calculus, you'll learn a different way to do this, but we're going to use our good algebra skills. So let's see. The limit as x goes to 0 of square root of 9 plus x minus 3 over x. And we're going to do the same thing, which we multiply by. Okay. So let's see if we can tap into the difference of squares. So you've got the square root of 9 plus x plus 3. You don't want to change the value, so you have to multiply the denominator. Okay, so let's see what we've got. The limit as x goes to 0 of, all right, difference of squares. So it's the square of this, 9 plus x minus the square of that, which is 9. And let's keep these. Okay, why is this nice? Like, yes, those cancel out, and this reduces to 1. So we've got the limit as x goes to 0 of 1 over the square root of 9 plus x. Take a square root of that, and then add 3. And I think we can evaluate that. It's 1 over the square root of 9 plus 0 plus 3. Oops. Get my eraser. Hang on. Just this part's under the radical. Whew. Okay. So this is 1 over 3 plus 3, which is 1/6. And next year you'll learn that that's the derivative for the square root function at 3. Awesome.